In that tutorial, take question number 1. Take question number 1. Right? This question was a past paper question. This is 2020, 19 question. Right? Okay. That question says, you have that paper, the tutorial? You have, no? In the group I put. Right? It says a smooth narrow tube ABCDE fixed in a vertical plane as shown in the figure. The portion AB of length 2 root 3A is straight to tangential at B to the circular portion BCDE of radius 2A. The ends A and E lie vertically above the center O. A particle P of mass simple m is placed inside the tube at A and gently released from rest, so that the speed B of the particle P when OP makes an angle theta greater than pi by 3 less than 2 pi with OA is given by this answer. And find the reaction on the particle P from the tube at this instant. Also find the reaction on the particle P from the tube in its motion from A to B, so that the reaction on the particle P from the tube changes abruptly. Abruptly means people instantly, right? Instantly. When particle P passes through B. That is the question. Okay, now we will draw the diagram. Right. Right. Tangential mean it is perpendicular to radius at that point. Huh? This is tangent. Right. Tangential means at that point, this line is perpendicular to the radius. That's the meaning of tangent. Particle M is placed here. If the point is A, if the point is B. It is C, D, it is E. This is O, the point O. The radius is 2a. This angle given as theta. Angle is theta. No, pi by 3. No, this is given as pi by 3. Okay. The portion AB of length, this AB length, people this AB length is 2 root 3a. AB length is 2 root 3a. Right. Right now? Okay. Now, ask him to find the velocity perfect square. Right. When the particle, right, people, the particle moves on this AB part with constant acceleration. Okay. And after reaching to the point B, the straight part will end. Thereafter, particle moves into the circular tube and begins to move like this in a circle. Up to this position, particle moves inside this AB tube. Thereafter only that begins the circular motion inside the tube. Once the particle reaches this point B, this line joining center and the particle, that means this radius, makes an angle 60. Then once the particle comes into the circular tube, and when we join the particle and O by a line like this angle going to be more than 60. Okay. Therefore, I'll draw here particle. Then normal reaction coming. And this normal reaction. Now, particle, when it comes into the tube, the particle will make the outer inside the tube in a outer surface. That means inside this surface, the particle make contact. Therefore, the reaction coming towards the center like this. R. And the weight tax people, this way, mg. Suppose at this moment the velocity of the particle along the tangential direction v. This angle now theta. Right. If this angle, this is vertical now, right? This mg also vertical. Therefore, this angle also theta by alternate angles. This is theta. This also theta by alternate angles. Now to find the velocity v of this particle, we can apply conservation of mechanical energy. Conservation of mechanical energy. Right. Here, when the particle is released, it has no velocity, it has only potential energy. And once the particle reaches here, it has both kinetic and potential energy. Now I have to select a level for potential energy 0. I will take that level like these people, the horizontal level through O. As I select as my potential energy 0 level. Then there we need this height. This height we need. That can easily be found, people. This 5/3 angle, this radius when I consider. This radius, people. This radius, right, when I consider up to this point only the straight part of the tube available. Therefore, it is 90 here because we are given this AB is the tangent, right? AB is a tangent. So therefore, it is 90 here. AB straight part of the tube is tangent to this circle. Tangent means that line perpendicular to the radius at that point. This is 90. So now this height you can write OA height. This is 60. OA sine 60 is this 2 root 3 because here 90. OA sine 60 is equal to 2 root 3A. OA opposite side is CB, sine 60, 2 root 3A. Sine 60 you know, root 3 by 2, 2 root 3A, root 3 cancel down. OA equals OA. That OA height we need to write the potential energy of the particle, right? Now you can write applying conservation of mechanical energy. Here, total potential energy is mg OA. mgh. No kinetic energy. Here, potential energy, people, this height we need. From here to here, it's 2A. This is theta, therefore this height is 2A cos theta. mg 2A cos theta. mgh, no? mg, this is 2A, right? This is 2A. This is theta because when this angle is theta, by alternate angles is also theta. Then this radius is 2A. 2A cos theta is this height. And plus half in the square. In you can cancel down. By simplifying this, multiplying by 2 and taking this 2 times this side, we get this answer. Here now we get 80 gives this side. So dA cos theta is equal to V squared. Then here we have the A. We can take 4GA out. After take 4G out, here 2 minus of 2. Right? This is the velocity. And ask him find the reaction on the particle P from the tube at this moment. Now, at this moment, the reaction asking. Then we can apply F equals ME. Applying F equals ME towards the center. It is R plus mg cos theta equals centripetal acceleration going to be m v squared upon the radius. Radius is 2a. Yeah? Then we'll take this mg cos theta right hand side, m upon 2a. If g squared, we write by this 4ga 2 minus cos theta, take this right hand side, minus mg cos theta. Here this 2a we can cancel down here. Right. Now I can take mg out. Then take mg out. We have 2 by 2 we can multiply here 4. Here minus 2 cos theta minus cos theta minus 3 cos theta. Right now we have 2 and 2 make 4. 2 and this minus cos theta means minus 2 cos theta, and here minus cos theta minus 3 cos theta. This is in the coming. Right. You can very clearly notice, people, this R mg times this part within the bracket. This part within the bracket always positive. How do we see it? You know this cos theta, here we have subtraction. No? Let's see what is the maximum value of this 3 cos theta. So 3 cos theta will take maximum value when cos theta is maximum. Maximum value of cos theta is 1. That's occasion, even this 3 cos theta will be equal to 3. When cos theta is 1, 3 into cos theta, 3 into 1, it is 3. 4 minus 3 is 1. Right? That means when we subtract maximum possible value this can take from this 4, still this is positive. That means this R is positive for all values of theta. That means the reaction acting on the particle soon after entering into the tube, the circular tube, towards the center. That's what this says. R positive means that. Soon after entering into the circular tube at the point B, the normal reaction acting on the particle acts towards the center. That's what this R positive says, right? So then you can mention here R is positive for all theta. Okay, R is positive for all theta. Right. Now, next one. Find the reaction on the particle P from the tube. And people, when I substitute here theta, pi by 3. Theta pi by 3 means when the particle comes to the point B, I am going to find the R value. Okay. Now, when the particle comes along this straight tube, right, once it reaches the point B, just before reaching the point B, the particle is in contact with this tube. Just after reaching the point B, just after means 0 seconds. After 0 seconds, reaching to the point B. Just before reaching the point B, particle is in contact with this straight portion of the tube. Just after, particle make contact with the circular tube. Okay. So then at the point B, just before and just after, you can very carefully think, just before straight part of the tube, just after circular part of the tube, just after, right. So then you can see when r when theta equals pi by 3. When theta equals pi by 3, I am going to find this r. R equals mg 4 minus 3 cos pi by 3. R equals mg times 4 minus cos pi by 3 is half, no? Here 3 by 2 is 1.5. 4 minus 1.5, 2.5. 2.5 means pi by 2. R equals 5 mg by 2. What is this? Right. Just after the point B, just after point B, right? That means coming along the straight portion of the tube, particle now reaches B, and just after B, particle is in the circular tube. That location, the normal reaction acting biggest magnitude 5 mg by 2 towards the center. Now, I am going to find the reaction on the particle while it is moving from A to B. Here, look at this. Somewhere here I consider while the particle moving on the AB straight part of the tube, then there will be normal reaction, this thing is, because it's very obvious that while the particle is moving along the straight portion, it should make contact with this lower surface, 9. And the weight is mg. Right? And people now, by considering this motion of this particle, when we apply F equals ma this way, you can find the acceleration with which the particle moves along the straight portion. Right? You know, when the particle is moving along a fixed plane like this, if this angle is theta, once the particle moves this direction, you can very easily understand the component of the weight along this way, mg sin theta. Right? Now for this particle, if we apply F equals ma, this direction, if is the cos, it is mg sin theta equals m times a, m and m, you can cancel down, a going to be d sin theta. Right? Therefore, the particle is moving with constant acceleration along this direction. People, you know, once the particle moves this way with constant acceleration d sin theta, when we consider the motion of the particle perpendicular to the plane, this direction is mg cos theta, the component of the weight. Right? So now perpendicular to this plane, while the particle is sliding like this, particle does not go away. The particle is always in contact with this plane. So therefore, particle has no motion perpendicular to this plane. Understood? So therefore, we can apply F equals ma this direction, then no acceleration perpendicular to the plane. That means this acceleration is 0, means the retardant force acting on the particle along this perpendicular direction of the plane should be 0. That means this S is equal to mg cos theta. Likewise here, you know, when I consider this way, people, right? Now here, this is 90. This is 60, therefore this is 30. This angle is 30. Right? If this is 30, people, this is also 30. Corresponding angles, if this is 30, this is also 30. Then when we apply F equals ma to this particle, this direction, S minus mg sin 30 should be equal to 0, because along this direction, no acceleration. Right? Then we can apply that direction. Okay, for the particle at applying f equals ma along this direction. What do you get? S minus mg sine theta should be equal to m times 0. No acceleration along that direction. No acceleration. Then Fc equals mg sine theta is half mg by 2. Right? This S is a constant value, mg by 2. Until what motion of the particle? Until the motion ends at B. Right? Once the particle moves like this S will be acting to this direction with the same magnitude mg by 2 on this particle until the particle moves up to the point B. Then just before reaching the point B, the reaction acting on the particle is this S, size is mg by 2, that is acting outward from the center. Understood? Why? The direction of this S is going away, this direction. So once the particle reaches the point B, this S is acting along this OB direction. Once the particle enters into the circular part of the tube, what is the reaction? R, 5 mg by 2. What is its direction? Its direction is towards the center. Then we can see just before the point B, the reaction was S of size mg by 2. It was acting in the direction OB, outward. Just after the point B, the reaction is R, that is acting inside towards the radius, towards the center of magnitude 5 mg by 2. So then what happens? Once the particle passes the point B, the outward direction reaction comes inward direction. Abruptly change means that people. Abruptly means suddenly changes. See here, the direction from outward to inward, the reaction changes. The sides also suddenly changing from 5 mg by 2 to 5 mg by 2. That's what in this case we have to prove. Then you can see this way. Now you can write here. Therefore, the reaction on the particle changes from outward to inward. From outward to inward. When it passes point B, when it passes point B. Okay, people? Right. That's how we take that answer. Right. Now take the question number 2 in it. Take question number 2. Right? I'll read question number 2. Right. That question is a smooth straight tube AB and a portion BC of a smooth circular tube of radius simple A with an angle of 2 pi by 3 subtended at the center, both of equal cross section. have been connected together as shown in the figure. The composite tube is fixed in a vertical plane such that AB lies on a horizontal plane. A particle of mass simple m is placed at the point A, and another particle of mass 2m is placed at the point B. The particle of mass simple m is projected into the tube with horizontal velocity simple u. The two particles collide and coalesce. You know, people, coalesce means after the collision, they move as a single object. That's the meaning, right? They move as a single object. That's the meaning. Coalesce means that. Asking some questions. Find the velocity of the composite particle of mass 3m after the collision. Okay, find the velocity of the composite particle at the point P and the reaction between the composite particle and the tube at this point, where OP is inclined at an angle theta to the downward vertical. If the composite particle moves through the tube and leaves it at C, then show that U greater than P times root 3 Ag. Fourth one asking if AB equals root 3A and if the particle of mass 3m which leaves the tube at C falls at A, so that U is this answer. Right? That's a good question, right? People, now we'll draw the diagram there. Hmm? Mass at the point B is 2m. This is 2m. And this AB length gives us root 3A, right? And this radius is simple length. When it comes to a position P, I'm going to mark the normal reaction theta going inward, weight mg, axis P downward, angle given as theta. Right, let us take the velocity along the tangent here as b, as b. Right. Now this particle comes to the point B with the same velocity u because this is smooth. Then we can apply conservation of linear momentum to find the velocity of the composite particle, right? So now initially here particle A of mass m moves this direction with velocity u. Here the other one 2m is at rest at B. Then we collide and they begin to move with suppose the velocity w. Mass is 3m. Now applying conservation of linear momentum this direction. We can apply conservation of linear momentum. Okay. Just before the impact, the total momentum of the system is equal to momentum of the system just after impact. Right. So then just after impact, the momentum is 3mw. Just before it is mu. Okay. Because this 2m particle is at rest before the impact. If you can down, then w you can subject as u by 3. So this is the velocity with which the combined particle begins to move with u by 3. Then here it begins to move with u by 3. Now here that is 3mg now because combined particle only coming here now. That begins here with velocity u by 3 now. The combined particle begins to move from the point B with velocity u by 3. Okay, right. Number second, find the velocity of the composite particle at the point P. Once it reaches here, right, I am going to take people this level as the potential energy 0 level. I am going to apply the conservation of mechanical energy, right? Applying conservation of mechanical energy. Initially, no potential energy. This has kinetic energy, right? So I'm going to write that initial energy of mass is now 3m. Velocity is u by 3. Therefore, u by 3 perfect square. At this point, the kinetic energy half 3m v squared plus. There we need this height. This height we need. That height can easily be found from here to here. It's a. This is a cos theta. Whole height is a. From a subtract a cos theta. A minus 3m g h. H is this. This a minus this part. A minus a cos theta. Okay. Then 3m you can cancel out. Multiply by 2. There is right hand side. There you get u squared by 9. This 2 will cancel off. Here multiply by this 2 to take right hand side minus 2 g, take this a out. 1 minus cos theta. The velocity v is the root of this. U squared by 9 minus 2ga times 1 minus cos theta. This is the velocity v. Right now, right. Now normal reaction asking. Now we can apply F equals ma towards the center. Applying F equals ma this direction. Right. Then I produce this straight line. If this is theta, this is also theta. Then F equals ma when we apply there, r minus 3mg cos theta. R is inward, 3mg cos theta outwards. R minus 3mg cos theta equals 3m times centripetal acceleration v square divided by radius c. Then r can be subjected. Take this 3mg cos theta to right hand side plus 3m upon a. For this v squared, we can substitute by this v squared by 9 minus 2ga 1 minus cos theta. How simplify this? R equals 3mg cos theta multiply this and this, 3 and this 9 you can cancel down, mu squared divided by 3a minus here a and a you can cancel down, 6 mg 1 minus cos theta. Now we will simplify this, minus 6 mg minus cos theta. When you multiply, we get plus 6 mg cos theta here, 3 mg cos theta, altogether 9 mg cos theta. Plus here mu squared upon 3a minus 6 mg is the normal reaction R. Right? Right. Next one asking if the composite particle moves through the tube and leaves it at C, then show that U greater than this answer. Now, composite particle people are coming to the air, leaving from the point C here. You know, since the particle is moving inside this tube, the normal reaction R does not disappear. That R is always acting on the particle. Its direction can be inward or outward, because once the particle makes contact with this inner surface, the normal reaction come in outward direction. If it move contact in this on this surface, normal reaction come in inward direction. So therefore, the condition required for the particle to come out from the point C, anyhow, if the particle comes out from the point C, that should come out from the point C, moving inside the tube. So in order to reach to the point C, the particle should have sufficient velocity until it reaches to the point C. So therefore, the condition required is once the particle comes out to the gravity air at C, the velocity of the particle at C should be positive. To the velocity only, the condition we can give. The particle should have sufficient velocity to reach the point C. If it comes out from the point C to the air, then the velocity at the point C of the particle should be positive. Velocity of the particle, once it reaches the point C, can easily be found equal this angle given as 2 pi by 3, 120. Okay. 120. Then we substitute that 120 we are here and we find this V. Then we get velocity at C. That velocity will be positive, right? Right? Velocity of the particle at C. Put theta 2 pi by 3 in V. So what do you get? V is equal to square root of q squared by 9 minus 2dA 1 minus cos 2 pi by 3 cos 120. You know cos 120 is minus half. Put here minus half. Then we here which is 1 minus minus 1 plus half. Then 3 by 2 coming. No. Here this is minus half. No. 1 minus half means 1 plus half. 3 by 2. 2 and this we can cancel down. We get 3 GB. Right? But when the particle comes out from C, we should be positive. But when the particle comes out from C, V should be positive. That means V square should be positive. Right? V square going to be this, no? V square by 9 minus 3GG positive. U square greater than 27 G8. Then take this positive square root of this. 27 you can write 9 into 3, no? 3 root 3G8. 3 root 3G8. That answer also coming. Now after reaching to the point people see it comes out with the velocity this. At that moment the particle moves along the tangent drawn to the tube at this point, along the tangent. This velocity I will take square root of this, no? I take that as V dash. What is V dash? V dash is this answer. Square root of U squared by 9 minus 3G. At that moment, this direction we can find the angle. If I draw horizontal line, right here 2 pi by 3, no? 120. When you draw horizontal line here, this is 90. Therefore, this is 30. If this is 30, this is also 30. Right? Here it is 90 now. Therefore, this is 60. The angle is 60. Okay. Now the particle begins to move as a projectile. As a projectile. Now asking if AB equals root 3A, and if the particle of mass 3m, which leaves the tube at C, falls at AR. The particle now moving under gravity, it falls at A like this. Okay. As a projectile motion, now it moves. Now asking to show this you this answer. Now we have projectile motion. Now you can see the horizontal distance or the displacement this particle has moved after leaving at C and coming to the point A. The horizontal displacement moved this root 3A plus this part when I draw vertical line like this. This part, this length plus this length is the horizontal displacement the particle has moved. And the vertical displacement the particle has moved is here. This is A and this is A sin 30. Here this is 30. This is A. Therefore, the opposite side is A sin 30, A by 2. Then particle moves during this motion as a projectile to the horizontal direction. This root 3A plus this part A cos 30. Vertical downward, it moves A by 2 plus A, 3A by 2. Then that is our in hand question. Okay. Then we can apply the equations for this projectile motion. Then I'll draw that as a projectile motion like this. Particle is here now. The height 3A by 2. It moves with velocity v dash, making an angle 60 with the horizontal like this. This is going to be root 3A plus root 3A is this evident plus this then A cos 30. A cos 30 means A cos 30 means cos 30 root 3 by 2. Then here root 3A by 2. So what is this total? This total is 3 root 3A by 2. Then we apply the equation of motion for this. Right? We can apply this equals ut plus half at squared vertically upwards for the motion. For the motion CA, C to A. So what is the velocity? V dash sin 60 upwards is. Now from here, final particle is here. Particle has purely downward direction displacement. But since we apply this equation upward, that 3A by 2 should be negative 3A by 2. U V dash sin 60 times T plus half minus G T squared. Okay. 3A by 2. Don't substitute for this V dash sin 60 root 3 by 2 v dash t minus half dt squared. Let us take this as number 1. Now we apply s equals ut horizontally. We apply s equals ut horizontally, right? S equals ut, you can apply horizontal rightward. This limit is going to be 3 root 3a by 2 equals v dash cos 60 times t. Then here you can substitute for cos 60 half t, this and this you can cancel down. T can be subjected 3 root 3 divided by v dash. Now that answer of t we substitute via here and here. I will simplify this. Then you get this answer for you. Okay. Substituting in number 1. Right. Substitute and take the answer with. Right. So then here you can put 3a by 2 minus root 3 by 2 v dash t 3 root 3a 3 root 3 divided by v dash minus half d t squared. T squared means people here 3 root 3a perfect square divided by v dash squared. 3 root 3 perfect squared is 27. V squared divided by v dash squared. Here is v dash, and this you can cancel down. This 2 here, this 2 here, and this 2 here you can cancel down. And people, here we have 3, here we have 3, here 27 divisible by 3, no? Then this 3, this 3, this cancel down here 9. Then here we get minus a. Root 3 and root 3 is 3. 3a minus here 9g a squared divided by v dash squared. V dash, people, I have marked, I erased that over there we have, no? V dash squared means that answer. It's u squared by 9 minus 3ga. Okay, right, bring this to this side. 9ga squared divided by u squared by 9 minus 3ga. Take this side, that will be equal 4a. Now, 1a you can cancel down with this and simplify this, you must get this answer. So 9ga in the left hand side. Use the cross multiplication for this end. It is 4 times u squared by 9 minus 12ga. Take this to the side. 12ga plus 9ga is 20. 1ga is equal to 4 u squared by 9. Then taking the roots of all, root 21, root GA, 2 by 3 U. Now the answer coming, no? Use the answer U 3 by 2 square root of 21 EA. This is how we take that answer. Right. As for next question, people will take question number 8. Take question number 8 in the tube. Read question number 8. Right, question number 8. Question number 8. A particle is suspended by a light inextensible string of length A from a fixed point, and the particle is given a horizontal velocity u when it is at the lowest position. So that for complete revolutions, u square should be greater than or equal to 5 GA, and the string should be able to bear a tension of magnitude 6 times the weight of the particle. Part B, if u square equals 7 GA by 2, show that the particle leaves the circular path at a height 3A by 2 from its lowest point, and after moving a time root 6A upon G in the gravity, it reaches to the initial position. Right. Now, this way, right? Suspended, right? I'll take this point as O. By light index of the string of length A. Right. Let us take the mass of the particle is simple limb. Is given a velocity u. And now I'll take, once the particle reaches to a position like this, the tension in the string as T, this angle theta, velocity v, weight mg. And now the potential energy is 0 level. I take like this. Then I'm going to find people the velocity v and the tension T. Right. This is T equals 0. Instant T equals T instant. Applying conservation of mechanical energy over there, I'll take the potential range is 0 level at this level. Here, half mu squared minus mga is equal to half mv squared. This height we need. This depth we need. It's a cos theta, but minus. Right. The radius is a, no? Then we can find this v squared first. Cancel down this m. Multiply by 2. Here we have v squared. Here this is v squared minus 2ga. You get this side plus 2ga cos theta. Right. We can write f equals me now, secondly. Towards center. Right? Right. T minus mg cos theta. Equals mv squared by a. M upon a takes the right hand side. V squared is this answer. Plus mg cos theta. Right. Now we'll find tension T here. Right. Now V equals the bracket mu squared over a here minus 2mg plus 2mg cos theta plus mg cos theta. Then here you can simplify this furthermore. Right, 3mg cos theta. Right. What is the first question asking? So that for complete revolutions, for complete circles, that is asking, right? Complete circles, right? U square greater than or equal to 5GA. What is the condition required, people? For the complete circles, at the highest point here, the tension T should be greater than 0 or equal to 0 also possible. Greater than or equal to 0. At the highest point means theta 180. The condition required for complete revolutions for complete revolution, P at theta equals pi should be greater than or equal to 0. Put pi here. Mu squared by A minus 2mg plus 3mg cos pi greater than or equal to 0. Mu can cancel now. Q squared by A. Here, cos pi is minus 1. Then here, minus 3g greater than or equal to 0. This gives us U squared. Bring this both to right hand side greater than or equal to pi g A. The answer is coming. Next one asking what? And the string should be able to bear a tension of magnitude 6 times the weight of the particle. Yeah, now I'm going to find this. The tension value, maximum tension I am going to find. Maximum tension, for this tension to be maximum, cos theta must be maximum. Okay. Then tension becomes the maximum value when cos theta is maximum. Cos theta maximum is 1. For cos theta to take 1, theta should be 0. So therefore, the tension in the spring will be the greatest when the particle is projected. When the particle is projected. Okay. Then you can write like this. The tension is maximum when cos theta is maximum. When cos theta is maximum. Cos theta maximum is 1. Cos theta maximum is 1. This occurs when theta equals 0. This occurs when theta equals 0. This occurs when theta equals 0. That is T theta equals 0 equals mu squared upon A minus 2mg plus 3mg. Cos theta is 1 now. This is the maximum tension in the spring. This is maximum tension in the spring. Now, the tension value has U squared, but our U squared is greater than or equal to 5GA. Again, this tension at T equals 0 depends on this U squared. Then you know, at the very beginning, when we project the particle only, maximum tension occurs. That maximum tension occurring depends on this U square. But the minimum value of U square is what? U square should be greater than or equal to 5GA, no? The minimum value of U square is 5GA, therefore. Then when U square takes its minimum value 5GA, we can put where here. Then we get here tension at the beginning, right? That is at the beginning only maximum tension occurs. When we take U square the minimum, we can now find the maximum tension. Below that tension, there will be no tension below that value. Because at the beginning, for the minimum value of U square, the tension we can calculate. Definitely that tension occurs in the spring. If the spring can't bear at least that tension, what happens? When we project the particle, the spring will break. Can you understand my logic? Maximum tension occurs at theta 0. That means when the particle is projected. That is this. That expression contains U square. Now again, at the beginning, that tension depends on U square. The minimum value of U square is 5GA. Once I take that here, at the beginning, the minimum tension comes. When you project the particle, the minimum possible tension occurring in the string we get. Below that level, below that value, the tension in the string never occurs. Therefore, the string should be able to bear at least that minimum tension. If not, what happens? When we project the particle, at the beginning, the string will break, right? Therefore, T equals 0 minimum. Initially, when the particle is projected, the minimum tension we can expect is what? Substituting for this U square, the minimum. M upon A, U square minimum is 5GA. Nothing. This is now 6MG. Therefore, we can expect whenever we project the particle to keep our U square 5GA or more. When we keep our U square as 5GA, then this is the tension at the beginning occurs in the string. If the string can't bear at least this, what happens? When we try to project the particle, string will break. So therefore, this way, at least 6MG, it should be able to bear. That's the answer. Okay. Now, part B asking people, if U squared equals 7GA by 2, so that the particle leaves the circular path at a height 3A by 2 from its lowest point, and after moving a time this much in the gravity, it reaches to the initial position. Now, you know, when the particle leaves the surface, the particle leaves the circle really when tension becomes 0. Okay, so now to find out that position where the particle leaves the circular motion can easily be found by using this, right, tension, no? Right. I write the tension expression here. Tension expression is T mu squared upon A minus 2mg, right, plus 3mg cos theta. Right. And the velocity we need, velocity we found u squared minus 2ga plus 2ga cos theta, no? Right. We are given here u squared equals 7ga by 2. U squared equals 7ga by 2. U squared equals 7ga by 2. Here this one. Then we can write T. Substitute for this u squared 7ga by 2. What is that? M upon A u squared 7ga by 2 minus 2mg plus 3mg cos theta. This you can cancel that. You know, when the particle leaves the circle, what can see? Tension T equals 0. Tension T equals 0. Tension T equals 0, right? Then we can put here 0. Right. Then we get T. Is this now 7 mg by 2 minus 2 mg plus 3 mg cos theta equals 0. You can cancel down this mg. In cos theta, you can subject, take this right hand side 2 minus 7 by 2, here 3. Here we get minus 3 by 2, no? Here 3 cos theta. 3 and 3 you can cancel down. That gives us cos theta minus half. When cos theta is minus half, equals theta 120. Theta is 120. Theta 120. That means the particle leaves the surface circle when theta is 120. Theta 120 means up to here 90, no? Here this is 30. Somewhere here, particle leaves the circle. That location I can find the velocity. I'll take that velocity as W. Thereafter, the particle will be moving under gravity as a projectile motion. Right? Now, to this point, ask him to find the height. If this is 30, this is also 30. This length is A. If this is 30, this height you can find. A sin 30. Then to this level, the height from this level going to be A plus A sin 30. 3A by 2, no? That first, that answer can we can take. Right. Right now, therefore the height. It is V plus V by 2. This is nothing but VA by 2. Hmm? That is okay. Next thing, we need to find that W, the velocity at that moment. That can be found putting that theta 120 here. Okay. Now you can write W square. Substituting U square is what? 7GA by 2. Right? I use this equation, people, right, to find the velocity of the particle at this point. That is when the particle leaves the circle. That velocity V I took as W. That is why I wrote W square here, but U square given 7GA by 2 minus 2GA plus 2GA cos theta at that moment is minus half. Then we'll simplify this. Right? We can take 2 as a common denominator there. 7GA minus 4GA minus 2GA. 7GA minus 4GA minus 2GA. Then we get GA by 2. This is the W. Okay. W is root GA by 2. This velocity, with this velocity only particle begins to move. Now what is asking, people? Next one asking like this. After moving a time square root of 6a upon g in the gravity, it reaches to the initial position. Right. Now we have what? Projectile motion. Now we have projectile motion. Like that, I am going to draw in a separate diagram to get a clear idea. To get a clear idea. Now here, the point O, here the lowest point. Its height is A. This is A. Now, this angle is 30. Here the particle starts with velocity W, a projectile motion. This height is VA by 2. This length, what people? This is 30 now. This is A cos 30. Root 3A by 2. Then asking this way, while the particle moving as a projectile motion, it comes to the initial point of projection. After time, this much. How to do that now? After a time this much, it passes to the point B. Then we can apply equation of motion. When we consider motion from here to here, I take it as point X and this as point Y. When the particle moves under gravity as a projectile motion, it moves from here to here. Then its horizontal displacement is root 3A by 2. Vertical displacement is 3A by 2. Then first I am doing this way. First of all, I am going to calculate the time it takes to move the horizontal displacement this much. Thereby, we show this time is the answer given. Thereafter, during that time interval, I am going to find the vertically downward direction, the displacement the particle moves. If that displacement particle moved during that time interval is equal to this 3a by 2, what can you say? While the particle moves leftward, this distance root 3a by 2, its vertical downward displacement 3a by 2. What happens? Particle should move definitely to the point this, right? Okay, then we can write this way. S equals ut, we apply this way for the particle for x to y motion. S is root 3a by 2. U, when you draw horizontal line here, if this is theta, this is also theta, this is 60. W cos 60 into T. W, it's root GA by 2 cos 60 half time T. This and this you can cancel down. By this root 2, when you multiply this, we get root 6. This A and this root A you can cancel down. Here we get root A. Root 6 A by G coming here as our T. Yeah, for T is equal to root 6 A over G. This is the time the particle takes to move horizontally this displacement. Now I am going to prove during this time, from here, particle descends 3a by 2. During that time interval, particle descends 3a by 2. Then during that time interval, particle moves to the left, root 3a by 2, and descends 3a by 2 downward. Therefore, after that time, particle should definitely move this point. Okay. Then the another one, apply S equals ut plus half area square downward. We have to prove during this time interval, the vertical displacement downward direction of the particle is equal to 3a by 2. For the displacement, we have taken answer 3a by 2. Then that completes the question, right? Right, now we can applying S equals ut plus half at square downward direction. I'm going to calculate this. People, yeah, yes, downward direction. U here, W sin 60. Upward only that initial velocity available, but we apply that downward direction. Therefore, that U should be minus W sin 60 times T plus half AG T square. S is equal to minus W root GA by 2 sin 60 root 3 by 2 T. Root of 6A by G plus half GT squared 6A by D. Now we can simplify this. This G you can cancel out. Root A, it's A. Right? And this root 2 and this root 6, we can cancel down. We get root 3 here. That root 3 and this 3 make 3. Okay? Correct, no? Another 2 here we have. This 2. Root 2 and this 6 we can cancel down. Root 3 come in here. That root 3 and this root 3 is 3. I wrote that. This 2 is here. E and G we cancel down. Root A. Here, plus this 2 we can cancel down. Here we get 3A. In SC's people, 3A minus 3A by 2. 3A minus 3A by 2 means 3A by 2. All right. During that time interval, particle descends downward this height. Therefore, particle moves to the point of projection. Then you can write particle moves to the point of projection while moving under gravity as a projectile motion. That we can complete the answer. Right, question number 5. It says a smooth hemispherical ball of center O and internal radius simple A is rigidly attached to a point C located on a fixed horizontal plane such that its brim, brim means people that circle edge. We should say that as rim, the same thing. Is inclined at an angle 30 degrees to the horizontal as shown in the figure. The lowest point of the brim of the ball is A and the highest point is B. The points A, B and C lie on the same vertical plane. The particle P of mass simple m is kept at rest at the point A and given an impulse I in a direction perpendicular to AB so that it moves in the plane ABC along the inner surface of the ball. Right. Go to the diagram. Radius A. Start. Here the particle is given an initial impulsive force I. Impulsive force I given here. Mass of the particle is simple m. Here. Find the initial velocity of the particle p. How to find the initial velocity of the particle p, people? This point given as b. This is c. See, this is o. We can apply I equals delta mv. This I equals delta mv we learned where? I think in impact of elastic bodies we learned, no? Impulsive force defined to be change in momentum. Delta mv means difference of momentum. Final momentum minus initial momentum. Now we'll assume this velocity soon after the impulsive force I, the particle takes as u. We'll take it as u. This velocity u. Now you can apply I equals delta mv. Applying I equals delta mv this direction. I is the initial impulsive force. Final momentum mu. Final momentum here means people after giving the impulsive force. It's a velocity u we assumed. Therefore, the momentum is mu. Initially, it was at rest just before giving the moment impulsive force I. Then there we can subject u is equal to I upon m. First part is okay. Find the velocity of the particle p and the reaction on it from the ball when it is at a point between C and B, such that the angle OP, angle that OP makes with the downward vertical is alpha. Right. Between C and B, we are asked to find that. Somewhere here, suppose. Particle. Here, normal reaction is R. Weight is mg. This angle is alpha. Downward vertical, right? This velocity, suppose v. I take this level as the potential energy 0 level. Right. After giving this velocity u, now particle moves inside the ball this way. Then we can apply conservation of mechanical energy. And F equals ma, we can apply. Thereby, we can find the answer. The particle is P. OP is this. Angle OP makes with downward vertical is alpha, right? Then you can write applying conservation of mechanical energy. Initial energy half mu squared plus this height we need. That height can easily be found, people. Right, from this whole height, if this is 30, when you draw horizontal line, this is also 30. Then this is A, this is 30 means this is A sine 30. A sine 30. Sine 30 is half. Therefore, this is A by 2. Therefore, this is A by 2. This is A by 2. Then mg A by 2 is equal to half mv squared. We need this height. The whole height from here to here A. This part is A cos alpha. From this A, when you subtract A cos alpha, we get that mgh. Whole height is A. From that, subtract A cos alpha. We get that. Then you can cancel down this m, multiply by 2, and find that v square. Here, u square plus va equals v square plus, take this a out, we multiply by 2, no, 2ga 1 minus cos alpha. Now subject v square. U square plus VA takes this side minus 2GA 1 minus cos alpha. Ask him to find the velocity, no? That means root of this. Right. Now we'll apply f equals ma next. R minus if this is alpha, this also alpha, mg cos alpha equals mv squared upon 8. Okay, this is 8. R can be subjected m upon a this v squared. Put v squared down so here. U squared plus GA minus 2GA 1 minus cos alpha is the v squared part plus mg cos alpha plus mg cos alpha. Simplifying this, you can find this R. Simplify this people and find R. Right. When you simplify here, we get R mu squared upon A. Remove the bracket by multiplying m upon A. It will be mg. A and A will cancel off here minus 2mg. A and A will cancel off 1 minus cos alpha plus mg cos alpha. Now this is equal to mu squared upon A. Here plus mg, when you remove here, bracket minus 2mg coming, minus mg, this and is plus 2mg cos alpha plus mg cos alpha is 3mg cos alpha. Right, this way we get that V and R. I am going to write here now. V is equal to this u squared plus GA minus 2GA 1 minus cos alpha root. Now R. Mu squared by A minus mg plus 3mg cos alpha. Right. We found both. Third question asking people this way. If the particle travels up to the point B, so that, right. If the particle travels up to the point B, that means people particle now moving like this. If necessary, particle can leave the surface of the ball and it can begin to move as a projectile motion under gravity. No obstacle, because in this case, particle is really moving, not in a tube, not in tube. When the particle moves in a tube only, right, it can't move outside from the tube. In this case, if need the particle can leave the surface of the ball and begin to move under gravity as a projectile motion. But if the particle, people, comes to the point B, then until the particle reaches to the point B, particle is in contact with the ball. Therefore, in this case, to take the condition required for the particle to reach the point B is, at the point B, the normal reaction acting on the particle should be positive or zero. Zero means what happens? At the point B, normal reaction zero means, then at the point B, particle begins to move as a projectile motion under gravity. So therefore, remember, in this case, we can't take the condition required by using the velocity, right? By using the velocity, we take the condition if the particle can't move. If the particle can't come out from the circular motion to what? Projectile motion. This is really happening when the particle moves in a tube, circular tube. Then, when we take the condition, when the particle moves in a circular tube only, we use the condition using the velocity. In all other cases, we use this condition, right? We take this condition by using tension T or normal reaction. Then, if the particle travels up to the point B, show that I greater than or equal to this means at the point B, the normal reaction should be either positive or zero. Then you can write, if the particle moves up to the point B, then at the point B, the normal reaction of the particle should be greater than or equal to zero. Right. Because when the particle is at the point B, what is this alpha angle? This alpha angle, right, will be what when the particle is at the point B. Here, this angle, you know, here 30, then this is 60. When the particle is here, if OP turns this way, and this line OP will be on OB, giving this alpha 120. Alpha 120, right? So therefore, then alpha is 120. Put that 120 here. Therefore, R at B equals mu squared upon A minus mg plus 3mg cos 120. plus 120 is minus half, no? R at B. Can you stand over A minus MB minus 3MB by 2. But R at B should be greater than or equal to 0. R at B should be greater than or equal to 0. We get MU squared by A minus 5MB by 2 here, no? Greater than or equal to 0. M and M you can cancel. Now, take this to right hand side, 1 by multiplying by A, 5 VA by 2. But U squared, U is divisible, I squared by M squared. I squared by M squared will be equal to 5GA by 2. Then you can write I square root of 5GA M squared by 2. I greater than or equal to M square root is M. We multiply this numerator and divided by 2. Then this 2 will be 4. Its root is 2. M by 2. Here now 10. 10 E A root. I use this now. Right. Now, fourth condition. If I greater than, fourth one given like this. I greater than M by 2 root 10GA. Simple. This part is this. In this condition, this greater sign only here used. What do you mean by this? I greater than this. That means what, people? When the particle reaches to the point B, the normal reaction is positive. That means until the particle actually make contact with the inner surface of the ball, until the particle comes to the point B. That means particle, anyhow, people comes out to the projectile motion. But this time, I greater than this condition used, particle begin to move projectile motion coming out the particle from B. That's the meaning of this. Why? I greater than this means this sign means what, people? This sign. R at B, at the point B, the normal reaction acting on the particle is positive. That means particle comes to the air from the point B. That's what it says. From the point B only, particle comes out to the air and begins the simple harmonic motion. Sorry, projectile motion, not simple harmonic motion. Projectile motion. Understood? Right. So there are people here. When it comes out from here, that will be along the tangent. Along the tangent. That means perpendicular to this radius. Here 90 now. Now, from this point, particle comes to the air. Suppose this velocity is W. I'm going to find this W. Then the particle begins the projectile motion with the initial velocity W. Once the particle begins the projectile motion, it is perpendicular to this OB radius. And then this moves like this. Okay. Then we need that velocity. When the particle begins the projectile motion from B. That can be found putting here alpha 120. That W we can write now. Write down. Now W velocity. W velocity we can write square root of Q square plus VA minus 2dA 1 minus cos 120. W square root of u square plus dA minus 2dA cos 120 is minus half. Hmm? Then W u square plus dA here. People, what do you get? This is 3 by 2, no? That 2 and this we can cancel now. Then minus 3dA. Then W we can write square root of u square minus 2. Is a W. Now people asking what? Show that for the particle to pass through the point A in the subsequent motion, it is necessary that particle now after leaving from here, while moving as a projectile motion, it is required to move to the point A. This is the point A. This is the point A. Particle need to move to the point A. Then asking for this, the initial impulsive force should have the size this much. Right. Now we have projectile motion. Now, once the particle moves from here to here, right, its displacement, right, along this BA, its displacement is 2A, and perpendicular to this BA, away this, above this BA, perpendicular to this BA, particle has no displacement. Then in this case, when you apply the equations of motion, remember, usually we are familiar to apply the equation of motion horizontally and vertical. No people. In this case, we apply equation of motion down along this BA line and perpendicular to this BA line. Calculation is very easy. Perpendicular to this BA, this direction, people, when we consider the displacement, while the particle coming from B to A, perpendicular to this plane, perpendicular to this BA, no displacement. Understood? No displacement. Thereby, people, apply F equals ut plus half AT squared for the particle perpendicular to this BA. For the motion from B to A, we can very easily calculate the T. During this time interval, the particle should move along BA distance 2A. Then what happens? The particle will be moving to the point A. Understand? Okay? Right. Now we'll apply that. Now you can write our u equals I upon mu, no? Right. Now, for the projectile motion, from B to A, applying S equals ut plus half AT squared, this is equal. Perfect plane, we put that. Okay. What is displacement? Just think like this. When we project a particle on the ground like this, from here to here, by considering the motion, when we apply s equals ut plus half a square perpendicular to ground, once the particle is here and here, it is on the same level. No displacement perpendicular to ground. Now take this horizontal plane, incline that like this. Once you incline that, it is like this now, still perpendicular to the plane, no displacement. That argument only here we use. S is 0. U, it is W exactly. W times T plus half acceleration due to gravity. That is the important one. Now, when we draw this way, people, vertical downward, that G available. Right. This angle is 60, therefore this is 60. We need the acceleration along this direction. If this is 60, this is also 60. Therefore, this is 30. Then the component of G, this direction is G cos 30. This is 30 now. G cos 30. That is point in this direction. Right now, if this is 60, this is also 60 by corresponding angles. This is 30, G cos 30. But we apply the equation of motion in this direction now. Therefore, it is minus G cos 30. Minus G cos T squared. G you can cancel down. Then we this side, then G divided by 2 cos 30 root 3 by 2 equals W. And here T. Then we can write T 2 to 4W divided by root 3D. This is the time particle takes. During this time interval, particle should move along with dA a distance 2a in order to pass through the point A while moving projectile. Now we can apply S equals ut plus half at squared. We apply this direction. Right? Definitely during this time interval, it should move this length 2a. This S is 2a. U, initial velocity. Initial velocity, people here. This W, when we resolve this direction, W cos 90 coming 0. No initial velocity. U is 0. Ut product is 0. Half. Acceleration. What is that? By this G cos 60. Arrowhead is pointing in this direction. G cos 60. G cos 60 is a T square. Square is 16 W squared upon 3 G square. Now, simplifying this, you get this answer. Right. 2a equals G by 2 cos 60 is another half. 16 divided by 3G squared. W squared is this answer. U squared minus 2GA. So 1G here you can cancel down. This 2 and 2 make 4. We can cancel down. This 2 and this 4 we can cancel down. Here we have A. And here we have 2 over 3G. U squared minus 2GA. Use some multiplication to be same. 3GA by 2 equals U squared minus 2GA. Bring to this side. U squared is equal to 3GA by 2 plus 2GA. U squared is that I squared upon M squared. Here 7, no people. 7 GA by 2. Then you can take I equals M times square root 7GA by 2. Multiply this and this by 2. Then here we get 4, take that 4 out from the root, that is 2M by 2. This is 14, no? Then we get the answer. Therefore, I is equal to M by 2 square root of 14GA. So this is the answer of I. Right, people? We get this answer. Right, some more questions in the second tutorial available. Some good questions available in paper. Now do them as homework. Right, I think this is enough for the field motion.